Hello, welcome. Let's try to solve another Leetcode problem today. 2492, minimum score of a path between two cities. So we are given a graph. So this graph, some of the nodes may be not connected, but definitely there is a connection between node 1 to node n. We are going to calculate the minimum path while we are traversing from node 1 to node n. It can be any kind of traversing. So for example, from node 1 to node 4, let me use this example. For node 1 to node 4, so what is the minimum path? So the path is 4 here, but for this node 1, it can still go to node 2 and go back to 1, and then to 3 and 4. So the minimum is gonna be 2. So this is basically DFS problem. We just need to use the DFS to traverse all the node. But while traversing the node, we need to check some of the edges may not be visited. But how can we include such kind of such edges? This is just from the coding. So in the coding, we need to before we check if this node is in visited set or not, we have to include the edge because the edge will always be connected. Let me just start coding. So I'm gonna prepare a graph as a default dict, and it is a list. So for U, V, and W in rows, and GU need to append a tuple of V and W, and similarly GV should append a tuple because this is undirected, so it should be V and W. Now we've prepared the adjacency list. Now we can prepare the DFS. Let me put a node first and give a path for this DFS. Now let's start the main function. Because I want to calculate the minimum path, so I'm gonna have a self.result as my global variable. I will give it a positive infinity, and then I'm gonna execute the DFS. It's gonna be starting from node 1. So finally, I'm gonna return self.result. I also need to prepare the visited set. So I'm gonna prepare a visited set. Inside, it's gonna be node 1. Now I can start my DFS. So for neighbor in GI, if neighbor not in visited, so visited should end the neighbor. But we wanna calculate the weight. It is the path about this weight. So the graph also include a weight. So for neighbor and weight inside this GI, this means it is always connected. If there is always a connected path, so we're gonna check it. So self.result would be the minimum, with the self.result with this W weight, and then we're gonna check if this neighbor is not inside. If it is not inside, we're gonna put it inside and execute the DFS with this neighbor. So here is the trick. So for the result check, we have to put it before this if check. If we put it inside, some of the edges may lose the information. So for example, maybe the possible result is 5. If we visited from 1 to 2, 1 to 4, and then 2 to 3, we didn't visit this 5. It may produce wrong answers. Now let me just submit it for the to check if it works. As you can see, it works. Now let me submit it to test all the testing cases. As you can see, it works alright. Now let me just put this line just below this if check. So some of the edge informations may lose. This is okay, but let me just submit it. As you can see, some of the edge information may lose. So for this example, the result is 1,885, but my result is like 7,000 around, so it is wrong. So this means I didn't consider the edge information. So for this example, if I visited from 1 to 4, 1 to 2, maybe I didn't visit this 5, and then 2 to 3. It is possible. Then I'm gonna return a result maybe 6. But for this example, it is 5, it is okay. But for other examples, it is not okay. So if it is like that, what we can do? If we were to insist to write it here, yeah. Now let me just submit the right version, because we need to check it just before the if. Yeah, if we put it inside the visited set, it means we just check the not. But here we're gonna compare with the at. Yeah, but what if we were to check from here? What is it gonna be? Let me find my version for this problem. So maybe here. Yeah. So yeah, if you were to check it like that, you have to check all the edges because you lose some of the information. Now let me go back. So here it's the same, the DFS, and here also the same. But here we need to check the edges. Yeah, if we were to check the result just below this if tag. So this means we're gonna check some of the edges. Yeah, visited add neighbor. Yeah, I'm not sure if this is a right result or not. Yeah, let me just run it and submit it. So this is okay. Yeah, even I put it just below this if tag. But as you see, I also prepared another loop. Yeah, I wrote it yesterday, but I forgot about it. Yeah, you see, because of this, I put it just below the if tag. It means some of the else information may lose. I have to check it again. After running the DFS, I have to check all the rows. If this U is invisited or this V is invisited, it means there is still connected ads. So I'm gonna check a result with minimum of the weight with the result. After that, I get the result. So this means if I put it just below, I have to check again. So why not I just put it before the if? I don't need to write these 3 lines. Yeah, I can save these 3 lines, as you can see. Yeah, if I delete it and if I put it out just before above the if tag, so I can save those 3 lines and make it work. Yeah, as you can see, it works and it's even faster than before. Thank you for watching. See you next time.